Greetings from the workshop here at Waterbury. My name's Marty, and this is the next video in a series about how I'm making a stainless steel Oona spout. So the last segment was all about testing the mold and trying to get good waxes out of it. And what I learned was that I couldn't do away with the problems that I wanted to do away. There was a section. There's sections in the front that had shrink, and also the surface finish was not that good. And though I could get a decent surface finish, it meant heating up the mold too much, and that made demolding and cleaning up the mold really time consuming. So it was time to do some research. So I don't really have any people that I can talk to that do this type of work. I wish I did. The caster does a lot of silicone molds that I use, but he doesn't do any metal. And his parts are really smaller. They're really just, most of what he does is either hardware for, kitchens and things like that, or sculptural pieces, which are molded in a completely different way. But at any rate, I did manage to find some information from wax manufacturers, and there's two things that came out of that. But let's talk about the design first, or the spout. So this is the way that the part is currently injected. You see there's a long section here. That's where the wax comes in. It divides up into four sort of streams and then flows up and fills the cavity of the mold. So the problem with this thin section here is that when liquids move through tubes, they lose pressure, and as the diameter of the tube decreases, the more pressure is lost over distance. So what I've got here is, even though I injected this at 100 psi, maybe only a fraction of that was available here at the mold. What I can do is I can improve that. The other thing that I got that I need to, the other thing that's bad with this design is that there are thicker sections back here. What you want to do with most molds is keep the cross section, so keep it the same thickness all the way through. And that's true for this part, except for these bosses. But I feel that these bosses are important. I need those here so that my clients who mount these on walls, or you, the viewer, when you need to mount them on a wall, can have something to screw into the back of the spout and sort of attach it. So this is an important feature, and I'm not going to do away with it. But this is sort of a problem for me. It creates the sinks on the surface, because what ends up happening is that this is thicker, so it stays molten longer, and then it shrinks at a different rate than the surrounding. So it tends to, like, when it shrinks, it pulls in the face up here. What I really need to do is fix it. I need to find some way of preventing the shrinks. So the one thing that came up in my research, and I found two essentially good resources, was that the best place to inject a mold is in a thick part, here instead of here. So that's one thing. The other thing that I could do is create a reservoir for these thick sections using a different material where the wax can remain molten, and then as it cools, it can use that reservoir to as a feeder, as it were, for the sections that are cooling. So I thought, heck, kill two birds with one stone, right? I'll inject through here, and that'll provide a reservoir. So yeah, that's what I did. So I made a backing plate for this, and so this is the new scheme, and it really didn't require much modification of the mold. Essentially, all I did was I drilled 2 holes in the back, and I added another back plate. So here, you've got wax coming in here. It spreads out, both ways, and then fills the mold this way. And notice that these are much larger than what I had on the other mold here, so or other wax. And this works pretty good. The the no the sink areas aren't as deep as in the other molds, and the other upshot of this is, that wrinkled surface, it's gone away. Yeah, it's like my dad used to say, "Parese aquavist ariatrod ground." Yeah, see. So I got lucky there, and honestly, I couldn't find any information about that in the wax information that I had. What I ended up looking for was information on wax or plastic injection, and sort of there's an explanation of that process, and the regular fix for it is to increase the injection speed. So for me, that would mean increasing the pressure of the injection so that the wax fills the mold faster. And these thicker sprues allow for less pressure loss, and so the mold fills very quickly. So I think I got lucky there, but I still have some a little minor shrinkages there. And what I ended up doing was, here's the inside, or the negative section, the positives. At any rate, this is where the wax fits over it. It's the core. I drilled some holes through the back section, provided a back plate like that, and then inject through there. So the next step is to make this out of a material that isn't as thermally conductive as aluminum, stainless steel. There's a couple of other ones, and try it and see what happens. Hopefully that'll solve the problem. What I can also do is I can drill inserts in here that are, again, stainless steel or something that's not as thermally conductive. And then I'll have a clear channel of sort of melted wax that the mold can draw from to fill as it cools. But we're going to try the simplest solution first, make this out of stainless steel or something else, and see how it works. So with that, I'm off to make another part, and it's just another experiment in the larger scheme of things. Okay, I machined a plastic version of the aluminum back plate here. It worked really well. The parts that I got out of the mold showed very little shrink on the face, and well, it turns out that this idea of having a reservoir of wax for the thicker areas to draw from works well. In fact, it's hard to notice the shrinks, but they're still there. They're measurable. In fact, that's what we'll do. I'll show you the difference between kind of the original injections that I did and this new version, and we'll just set up a simple little fixture to measure them. So with that, let me reset the camera and we'll go from there. Okay, so here's the setup I'm using to measure the part. So what I've got is essentially a giant V here that holds the part, and when I rotate it, it'll rotate around the center of the outside, the perimeter, and then you have to remember that this edge is slightly sloped, so I need to sort of rotate it to keep it at the same height. Now, theoretically at the same height, right? This dial here moves up and down, and each one of those little lines is 1/1000th of an inch. So as you rotate it, you can see that it's moving around a little bit. And okay, that's just the inaccuracy of the wax part. But then as we get here, whoa! That was a big divot. So that was, hold on, let me see if I can't do this right. It's about 25 thousandths of an inch deep. Okay. And let's see if we can't see what's on the other side. I don't think the other side is as severe here. Okay, so we're coming up on it. See, there's that little dip.
Whoops. Okay, so, what, three or four thousandths on the other side. Let's take a look at another one. This is, what am I doing here? So here's another one this one's kind of got a rough surface finish, and it's got some of those divots. Let's see, are we still at 0? We're still at 0, so let's rotate around. That should be the valley there. It's about 5 thousandths. Okay, let's rotate to the other side. Rotate to the other side. Coming up on, let's see. Let me re-zero that. So we get some sort of measurement accurately. So, is that 0? It's moving around a bit. Okay, well, we'll have to do the best we can here. So what do we have, about maybe 5 thousandths? Alright, let's see if I can't re-zero on that. And then let's move down. Yeah, maybe 5 thousandths of an inch. 6,000, something like that. And that's pretty standard for the old, and that's pretty standard for the old style waxes. So here's a new one. Let's see what we get with this. And I'm going to have a hard time seeing this. Let's see, where are we at? Because there's not much there. Okay. So there we go. We rotate down. I don't see that. Let me see. Hold on. What do I see there? A couple 2 to 3 thousandths. That's pretty good. Let's rotate to the other side. I don't know if there's anything on the other side. I can't really see it. Hold on. Yeah, there's not much there. Again, that looks like a 2 thousandths. Okay. I got to keep it centered so it doesn't do that. Looks like a 2 thousandths do it. I'm not really going to be able to measure that. It's just not within the accuracy of the setup here, because the waxes aren't very accurate, and the way I'm moving them. Let's try another one real quick. Let's see what I got over here. Okay, let me re-zero that. Okay, and supposedly that's about where it's at. So what do we have? A couple thousandths. That's pretty good. Realistically, that's good enough, because you can hardly see any of the light sort of changing in those areas. So those couple thousandths will get polished out when the part is cleaned up and polished. So I'm happy with this. I think at this point I'm done with a mold, and I can make these work. So next up, we got some fixtures to make.